Okay, so hello everyone. Today we will see here the non-recursive pre-order traversal. So what is here the non-recursive pre-order traversal? If we have to see here, so first you should understand what is pre-order traversal. So we know that into pre-order traversal, we generally start our traversing like this. We first visit our route, then we visit left subtree, and then we visit right subtree like this. This was a sequence into your, we can say, into pre-order traversal. Okay, so same sequence you should get here also. So if you could not watch my previous video about recursive traversal, so please go and watch that first. Then you can go here and you can watch this non-recursive. So into recursive, we have used the same function within its own body. That's why we were calling that kind of traversing as a recursive one. Here we will use a separate stack for traversing. That's why we will say this is a non-recursive. Here the complete mechanism we will do by our own. So we will require a special stack for performing this traversing. So we will see like how to implement. Actually, we have discussed that also, like how we can implement stack also. So what you can do, you can simply go and watch my previous video, like how we can implement stack and how we can perform a push and pop operation over any tree for insertion and deletion of respective nodes. So here now for this tree, if we now have to perform this non-recursive pre-order, non-recursive recursive pre-order, this is our requirement. We have to do this non-recursive pre-order traversal. So what are the steps actually? So steps are here again same, like we need to just follow here steps. So the first step is here, we should just print the node, then we should push that node into stack, push the node into stack, and the third is move towards its left. So these are some 3 steps we should follow. So how we can have those steps for again performing this traversal? So we will see this. So before that, again let me go here and let me just tell you how we can get here a pre-order traversal for this tree by using this steps or by using this algorithm now. So this is actually not the complete algorithm. We will see these steps with respect to the problem. So here, as I'm telling you, what is the first step? You should print the node. This is the first step. Print the node, push that node into stack and move towards its left. Okay, so here what I will do, I will just first print the node. So this is, let's say, my output. What I will do is, again, I will copy this because, okay, rather than copying, I will just write here the output. What is the output required? Output. So what output we are expecting first? Into output we are expecting first the root. So we know that all the time traversing starts from the root. So I will first consider this as your root, which is your current node. So temp or root, whatever the name you will provide, it will be first your phi. So this is your current node. So I will again just increase the size of this. So this is now your temp. Okay, so initially I will just consider this as your current node. So into output, what you will expect? You will expect now the phi should be printed because this is the node from where you will get your traversing. So I will get first phi. So that's it. First you will get phi. Then what is the next step we have? Push that node into stack. This is your step 2. So I will require now one stack where you will push your nodes into that respective stack. So let's say this is now your stack. So into this stack, what I'm doing, I'm first now pushing phi. So let me just push phi here. So this is phi. So again, let me increase size. This is here phi. Okay, I have pushed phi here. So this is my first node, which is added into this stack. Okay, this is the first node I have added. Next to that, what is your next step? I have printed node, I have pushed that node into stack, and now I should move towards its left. Again, I am telling you, like for implementation of this, you require to understand first the stack implementation. I have already explained that stack implementation into previous video, so you should watch that, then you can understand this one. Okay, so we will now again go with this problem. So what is the next step again? We should move towards its left. So we have printed node, we are pushing that node into stack, and now we are moving towards its left. So what is the left of current node? That is 4. Why I'm telling like this? Because this was your root and root's left is 4. Okay, that's why root is now what? Root is the left child of your previous node. So what I will do, I will again repeat the same step. That is what again? You should again print the current node. So current node is what? Current node is 4. Just print that 4, push that 4 into stack and move towards again its left. So I will again just try to write here. After 5, I am getting here 4. Okay. So this is your next node that we are expecting into output. So 5 comma 4 we got like this. So this is your next output. Again push that 4 here into stack. So this is 4. Size is I think 24. Where it should be pushed into stack. So it's into stack now. Okay, so don't go with colors are not important, only understanding is more important. Okay, so this is red. Okay, so now here for this one also, what we can do, we can also repeat again the same step, that is print the node, push that node into stack and move towards its left. So we are just following this step only. As of now we are just following this step. So now for this 4 again, what I will do, I will move towards its left. So for 4, the left child is what? Left child is here 2. This is your left child. So you will again print what? You will print that next node. So here the root will be what? Root will be now this one, that is your 2. Root is your 2. So again you will print that 2. I hope you are understanding, everyone who is watching this video. So here I will just again print this. So here the 2 is printed and then the 2 will be added into stack. Okay, and after that what you will do, again you will move towards its left. So for 2, what is left again? For 2, what is left? So left is nothing. We don't have any child as left. So as of now into stack, we have added these 3 elements. These are what? 2, 4 and 5. By what operation? By some push operation. So push operation we have performed here. We have performed this push operation for adding the nodes into stack. Okay, so this is the case till when we could just be able to print the nodes. We were pushing that node into stack and we were moving towards its left. But now at this instance, as this 2 doesn't have any left child, so what we can do now, we can now perform the next operation into stack, that is pop operation. So here I will write now the next step. So this will be a kind of different step. So I will say this is what? A 4. Okay, that step is what? Until stack is not empty. What we can do, we can pop the element from stack. Element means node. Okay, element means node from the stack. You are just popping the element or the node from the stack and you are moving towards its right. Why I'm writing right? Because we have already considered left is already covered, so we will now check for right. So this is your next step I can consider. So completely, if I will say this 1 2 3 steps we have already performed, now we are thinking for 4 5 6. So until the stack is not empty, you will do what? You will keep popping the element. So if I will now pop this element, which is what? Which is now 2. Okay, so 2 I will pop first. So if I will remove 2 from this, I am popping this 2. This is what? This is pop operation. You are popping 2. You are just popping here 2. So popping means you are deleting 2. So if you are popping this 2, so do check, can we have something towards its right? For 2 we don't have any right child, so definitely you can simply remove this 2. Okay, so 2 will be deleted from the stack. Now what is the next element we have here after deletion or after popping 2? Now we have 4. So you can again pop the 4 from the stack, and after popping 4 again go with the next step. So next step is what? Until the stack is not empty, keep popping the element from the stack and move towards its left. Okay, this is move toward its right, move towards its right. Okay, so do we have something towards its right, like for 4? Yes, we have. So what you will do now in this case, what you can do, so you can now repeat the previous 3 steps. Okay, if I will say these 3 steps are combinedly, I can say as my step 1. Okay, I will do just one thing. I will copy this complete thing now. So just this is it, like I require. Let me just copy this. Okay, I hope now it's visible. So what I will do is I will just try to arrange everything on single page. So this is it. So now here, what I am telling, I am just trying to tell you, if I will say this, all the 3 steps I am just referring as a step 1 or step A. Step A. Step A. This all the 3 steps are referred as step A. So your next step will be what? Next step will be here 7th number step. Step number 7. Step number 7. That is what? Repeat step A. So this step you should repeat again. Step A means you should repeat the previous step. If you are getting any right child, so repeat the previous step. That is your motto. Okay. So what we will do now, we have popped the 4. So now the stack will look like this, where again into this stack we will have this 5 as the single element present. Okay. So I will require this kind of same stack. I will copy this stack, again I will paste here. Into this stack again I will have same kind of structure. That's here like this. Red. This kind of structure we will have. So initially still we have 5 present. Okay, still we have 5 present into stack. Okay, apart from this, now we know that we have something as its right child. Okay, so what is that right child? Right child will be here 4. So so sorry, for that 4 we will have the right child as 6. So you will simply add here 6 you will add here. So just again let me increase the font size. So 6 I will just add into stack. I will print that 6 comma 6. Okay, so after 2 we are getting here 6. How I am just doing this? I am just following the steps. So what was the next step? Move towards its right. So we moved towards the right of 4. So 4's right was 6. Okay, so here this step became true. So as we are getting something towards its right, so we are doing what? We are repeating step A. So step A is this 3 steps. We are printing that node, so we have printed 6 here. Then we have pushed that node into stack, and now what I will do, I will try to move towards its left. So can we have something towards its left? We don't have towards its left anything. So what I will do is, again I will go with the step number 4. That is, until stack is not empty, just keep popping the element. So again you can pop that element which is at the top. So at top we have what? We have here 6. So again pop that 6. So if you will pop that 6, so your stack again will look like this, where you will just have a single element. So single element is what? Single element is only 5. So again what I will do, again I will do the same operation, like I will pop 5 also. Okay, so if you will pop this both the elements, you are popping both the elements. So after popping, what do we check? We all the time check, like, do we have something towards its right into step number 6? Okay, we are popping 6. After that, we are popping 5. So for 6, we don't have any right child, but for 5, we have a right child. So if you have a right child into step number 6, according to step number 6, so you will repeat what? You will repeat step A. So step A is your previous 3 steps. Okay. So here you will again require a same stack, where that stack will again hold what? It will hold your nodes. So again, let me just make that stack open. So into this, what node you will insert first? You will insert now the right child of that 5. So that is what? 3. So 3 you will insert. You require to print that 3 also. So you have now 3 with you. So this is 3. Insert that 3 there into your stack and print that 3. So again, you will print 3, comma 3. Okay, so after 6, we have now 3. Okay, so don't worry, I will make or bring it down. This is it. I hope you are getting this. So this is your next node which is printed. So we have printed now 3, and now after printing this 3, we have pushed that node into stack, and where we should move? We should move towards its left again. So we will follow this 3 step. So after 3, what do we have as its left child? So for 3, left child is what? 9. So again, I have a left child. So again, I will print that 9. I will push that node 9 into stack, and I will again move towards its left. So first I will do what? I will again print 9. Okay. So again, I require to make these changes. MS Paint should be updated. But okay. No issues. Okay. So this is again 9, which is here. So just go. Why it's happening like this? So this is last 9. Okay. So again, push that 9 here into your stack. So this is 9 again. For visibility, make it bigger. So this is 9. We have, I will push here into stack. So 9 is pushed. So after pushing that 9 into stack, move towards its left. So for 9, we don't have any left. We don't have any right. So what we can do? We can simply pop that 9 from the stack. I will pop this 9 from the stack. I will check, can I have something towards its right? We don't have anything. Okay, so no need to repeat step number 7, or no need to go for step number 7. Okay, so what node now we have after popping 9? We just have single node, that is 3. So just now pop that 3 from your stack so that you will get the stack like this. So stack is what? Stack will look like this, which is empty stack we have. Okay, completely empty stack. So if you have this kind of empty stack, and we have got our required traversal also, so we can say this is our expected output. And how now we can obtain this expected output? By using our code that we will see. So for this code, again, I will tell you what things we require. So just let me mention those things which we require for this code. So first thing that we require is here. Okay, that was your algorithm which we had seen. So the first thing that we require here for implementation of this code is what? You need to understand first how to implement single node. Okay, you should just able to understand how to implement a single node, that I have explained into first video. Okay, then you should know how to take input from user. For what kind of input I am asking? I am asking the input in terms of nodes. Okay, input means nodes. That also I have discussed into video number 2. Okay, and then you should know how to implement stack. Implement stack. This thing also you should know. So all these 3 things you should know. If you don't know this, then you can't understand now the program. So if you are aware about all the three things, then definitely you can understand now this current program. So it's again about this non-recursive pre-order traversal. So if you could not watch the previous three videos, please watch that, so that definitely 100% you will understand the current objective, that is to implement pre-order non-recursive traversal. Okay, so we will go here. This is code blocks. So into code blocks, you can see this block represents what? It represents the first node that will be available into your tree. This second class represent what? It represents a stack, which is consisting what? It consisting your push pop operation as well as a top. Size of that stack is 50. You can keep it anything. It will hold what? It will just keep the number of nodes. So I am just telling it's 20 as of now. Anything you can provide. After that, here you can have one create function which is taking the input from the user. So there can be n number of methodologies for implementation of this thing. Okay, so this is it. Just we can say for implementation of our pre-order traversal. So apart from this, now we have to implement pre-order. So I will just write here pre-order. Void pre-order is my function. So pre-order function takes what? It takes a node for traversing. So I'm just writing here as an argument. So that argument is what? That argument is your root or the node which we will pass through this function. So what is your first step into this? First step is you should print the node. So when you will print, whenever that node will be available with you, then only you can print. Okay, so what you will do, you will first write the condition while that node is available with us, then only you can print it. Okay, if that node is available, then only you should print it. That's the logic you should write. So when it will be available, when that value of node will be what? Not equal to null. So you can say root is not equal to, let's say, null, then only you should print that root's data. So I will just say I need to print what? I need to print here root's data. Okay, I'm just writing here /t for some spacing, root's data, this thing. So this is the meaning of your first statement. Until the root is not equal to null, keep printing root's data. That is your first step. Next is what? You should push this root into your stack. So again, we should use the push function, which is declared here inside this stack class. So this was a push function, which we have discussed into previous video. Okay, so here I need to just create any instance from stack class. So I'm just creating that instance as S. So by using this instance, I'm calling push function. So push s dot push. So what it will take? It will take that node. So I'm passing here root. Okay, so we have printed that node. Now we are pushing that node into stack. What is my current node? Current node is root. Okay, and next step is what? Move towards its left. So whatever is your current node, the next node will be what? It will be its left. So I will say root is what now? Root is its left. Okay, so what? Its left. So root is equal to root's left. So its meaning what? Its meaning is like root's new value is what? Root's new value is its left only. This is the meaning of this block. So these are what? These are your step 3 only. 1, 2, 3 steps that we have defined here. This is the meaning of this 3 steps again. Okay, so next step is what? Step number 4. So step number 4 is what? Until stack is not empty, what you will do? You will just keep popping the element from the stack and then you will move towards its right. So this is it. Like again, what we require again one more while loop where you will say s dot top not equal to what? -1. So what is the meaning of this? Like s dot top. So top is defining what? Top is telling you whether your stack is empty or not. So if, or we can say until that stack won't get -1, means won't get empty, till that time what you should do? You should just keep popping the element from the stack. So I will write s dot pop. Okay, but here you know that pop function takes what? Pop function is available here, node star pop. So here you can see like this function is what? A kind of pointer function. So pointer function will provide you the address of popped node. It will return the address of pop node. So here s dot pop will provide you the pop node. So you can store that into any variable. I will say that is again root. Okay, so root will store now you the popped element, which is the topmost element or the topmost element on your stack, we can consider. So apart from this, now the next step is what? After popping the element, what do we make? Apart from this, what do we make? So here, after popping the element from the stack, we move towards its right. Okay, so I will move towards its right. So root will be what? It's right. Root's right. This is it. Okay. The next step is what? Next step we have written. If you are moving towards its right, so next step is you should now repeat the previous step. So previous step means repeat step A. So step A means you should repeat all the three steps. So all the three steps are mentioned where? These are mentioned into first while loop. So what you can do, you can simply now consider this while loop as it is after this right statement. Okay. So I'm just copying this, I'm pasting here only. Now here this is the create function, which is as it is I have written. Then I have uh, just called here the create function into main, because first the user should ask or user should get the prompt to enter some inputs, and then after passing those inputs you should get the pre-order traversal. So pre-order takes a route which we have already passed while declaring pre-order function. So this is it. Now we will just try to run this. So let me save this, build and run. So you can see now we are getting the prompt like enter data. Okay, so how we are entering data here? Let's say I just want to create a new tree. So we have a space available here. Let's say we just have to create a tree like this with some 3 nodes. These are some 3 nodes. Okay, these are some 3 nodes we have. So add any value. Let's say this is 5, 4, 3, anything you can provide. This is 5, this is 4, this one is what, 3. So how do you can add this? So the prompt is coming like enter data. So I will add here 5. Then it's asking enter the left child of 5. So left child of 5 is what, 3. Okay, now the prompt is coming enter the left child of 3. So how does it work? I have explained into second video, that video number 2. If you could not again understand how the prompt is coming, please go and watch that video. So the prompt is coming now enter left child of that x, means that 3. So here it's getting stored where? It's getting stored at roots left. And for that we are also calling the same create function again. So create function is again asking you enter data. So you can now enter data. So when you will not create any new node, for this instance, whenever the x will be what, -1, so that you will return null. So if you are expecting the new node should be created, so for this you will say the left of 3 is what, -1, and the right of 3 is also should be what, -1. Okay, so in this case what I'm telling, okay, it was a 3, okay, it was 4, but I have written 3, not an issue. I will just change this, or what I can do is I will again run this. We have a time, so what we can do again, we can go here, we can run this. So enter data means again 5, left of 5 is 4, and this is -1, right is also -1. So here after this, if I'm writing -1 -1, so -1 means what, this will be here -1, this also will be -1, left and right child will be -1, means they will hold the address null. Here the address will be null. For this one also, this will be also null, and next here this one also will be null. So everything will be here like null, not an issue if you will provide a -1. Same thing you should do for 3 also. Like for 3 also, you should say this is -1, this one is also -1. So -1 means you will return null value. So this will return null. Also same, you can just follow here or do. It will return again null. So both. Okay, sorry for delay. Okay, this is null. So don't worry, though it's take time, you should understand this. So again, this right child of 5 is what? 3. 3 is the left child is what? We are telling it should be what? 3 is the left child is null and right child is also null. So null means you should provide -1 and -1. Okay. So what we are getting? We are getting here 543. So 543 is what? First we are printing root. Here the root is coming. First we are printing this root only, that is 5. After 5, then we are moving towards its left, that is 4. And after left, we are moving towards the right child. So this is how we are getting pre-order traversal. So this was just a non-recursive pre-order traversal. So I hope that you understood this. I know that the video was lengthy, but for understanding and for explanation, it takes time. So I hope you are understanding this. So please watch this, please practice this topic because it's important as far as your exams concern, as far as your placement concern, like for everything in data structure. This traversing is more important. So next time we will see how we can perform in order traversing. So thank you everyone.